Kelly, so according to the text, what angle has the maximum range? I'd say that would be a 45-degree angle. And what angle, what's the question? What angle has the greatest flight time? My text right here. And that would be a 60-degree angle. Well, on your paper it says 80 degrees. So 80 degrees would have the greatest hang time because it's the highest angle. And 45 degrees would provide the longest range because it's right in the middle of 90. And what is the next question? So, yeah, the 60 degrees angle would have the greatest hang time because it's determined by like initial velocity. The initial velocity, well, like considering like all, say like 3 angles were shot at the same velocity, 60 degrees would have the greatest because, you know, it's like vertical. The vertical velocity, yeah, it has like just the initial velocity would keep it up, and considering the angle. Enough of that. So, what's the next question? Did I answer why the greatest flight time is 45? Because, well, it's just, same thing, considering that they don't have any, like, wind resistance. About a 45-degree angle has the greatest range because, it's just right in between, the highest hang time. Okay, and moving on, sorry. Just trying to understand the effect on range and flight time. If the experiment was performed at a large vacuum room like the one at NASA's Space Testing Facility in Florida, well, I would assume that considering that it's a vacuum room that takes away all air resistance, I assume. So, I'd think that the experiment, that the rockets would have a greater hang time, but maybe less of a range, perhaps, because there's not much wind to catch to push the rocket away. Yeah, they're definitely going to have a higher hang time. Thank you. So that's what I would think if that experiment was performed at a large vacuum room like the one at NASA Space Testing Facility in Florida. Thank you very much.